Hello, welcome all. I'm Bart Warmdam. I'm a software developer at ING, and my talk is about access management with tokens in custom nginx modules. So what's my talk about? I want to talk to you about which modules we made, how they work together, how we use those modules for access management, and the lessons learned during the development of the modules. But to give you more insight on what use cases we face, I want to first tell you something about who is ING and why did we choose nginx and how do we use nginx. So ING is a bank. So we are active globally. We're active in over 40 countries. We have 35 million customers worldwide, and we have over 52,000 colleagues. But I work within the Netherlands, and there the numbers are a bit smaller. We have 8.1 million customers, which generate about 2.3 million page views a day on our site, and I work with 16,000 colleagues. So the numbers are a bit smaller there. And ING is split into different business units. So, for example, I work for domestic banking, and that means that all retail customers or small business customers are handled on that specific business unit, and large business customers are handled by different teams. So we manage the sites that are all related with retail banking or small business banking, but also for the general information site that we host, and also for all the mobile products that we have, like the application to pay for all those type of customers, so small retail and small business customers. So when did we start using nginx then? Initially we started late 2014. At that time we had an infrastructure on IBM Web Seal, which is an authenticating reverse proxy. And we wanted to migrate to different data centers. So with that came additional functionality that we required. So since that product did not meet our functional needs, we changed to use nginx and create additional modules for that. So we had to replace the functionality that we used for IBM Web Seal, and in this case was the authentication layer and the cookie jar, which acts as a store for cookies server side. So we had that to be created as nginx modules. But also we had to add additional stuff like monitoring or event publishing, so we can have a better monitoring in place than we had before. So by March everything was ready, and it takes a bit of time to get everything tested, especially if you are going to migrate to an authentication layer for your banking products. So by March everything was ready, and we migrated the first site in production. And after that we followed by migrating several sites one at a time. So all the domestic bank sites were migrated by July, and we also added an internal API gateway based on nginx during that period. To fit our needs, we also had to add an external facing proxy, like a reverse proxy for outbound traffic. Because in some particular parts of our site, we host an external site for example, social fora. So people can respond or look up stuff. And that's not hosted within our premises, but outside. And to be able to reroute that traffic coming initially in our data center, but then outside our data center, we had to also add an outbound proxy for that. And that also enables us to add the functionality to allow internal APIs to call external APIs as well. So that's our outbound functionality. And that was live by November last year. We continue to add functionality, so customers, for example, also upload documents to us as part of financial products or the getting to become customers, for example, or to upload more stuff. So we need to scan that for viruses. So we added modules in there to offload documents to a separate virus scanning solution. So these are also separate modules, also based on nginx. And in this case, the scanner solution is HTTP based, but we are in the migration to use the ACAP protocol. And since this type of solution with the inbound, outbound, and virus scanning solution is working quite good for us, also the other business units within ING are interested and now migrating to an nginx solution as well. So they are replacing their WebSeal solution. So by January, our wholesale banking colleagues, which are part of the bigger businesses, are migrating to nginx. And we started to integrate our cookie jar with persistency, so we could persist all the data that is in the cookie jar and store it in Cassandra. So once a request comes in and the node is not available and it's flipped over to another node, we can still pull all the cookies that were initially stored somewhere else. We can pull it in the cookie jar and handle the request as if it is handled by the same nginx. So we can transparently set up the session and load the cookies. So even if a cookie or if an application that's being called is sticky and requires an HTTP session on a specific upstream server, we can route that traffic still to that same server using all the cookies that we had initially for that on another node. So that is quite powerful for us to make sure that even if we fail over to other nodes or to other data centers, everything keeps working and the customer doesn't notice anything. By July this year, we started to set up the token interface because we wanted to move to a more uniform way of access. Because not only customers access our site, but also we have employees accessing services within the bank, but we also have application accessing our services as well. So we need a way to access management to allow access to services. So we created, or we are in the process of creating a new TokenAPI, which is a separate Java application which can manage all the tokens that we are consuming. For the last part that we are doing is also the integration of tokens, but also the move of all the employee-facing internal sites to nginx as well. So once that happens, everything is in nginx, and we can see all the traffic in there, and we can manage all traffic and access based on one single access way, and that is the access tokens that we use. And since all the sites are moving to more responsive ways of functionality, we are required to use APIs. So we need to expose the APIs in a safe and secure way, so other teams can consume those APIs, and APIs can be either consumed directly by other applications, or they can be consumed in the browser by applications that consume those APIs, for example, screens pulling data or initiating transactions. Some of the requirements to expose APIs is not only internal, so we can decide to put up an application, but we also have regulations where we have to abide to. So, for example, one of those is the Payment Service Directive, which required banks to open up specific financial products to outsides. For example, bookkeeping projects or programs externally hosted are required to get data from a customer so they can do their bookkeeping stuff on that package as well. So the exposure of APIs is quite important, and also the security to those APIs is important, and that's where we come in with the solution of nginx. So we can smart route to the correct upstream, but we can also add security constraints to that. And one of the constraints is the authentication module that we made, but also other constraints that we can add to requests. So we can, for example, move all the browser-related problems to one specific layer, in this case nginx. So all the APIs can talk with a clean interface to each other. But once we go to a browser interface, we can add additional security controls. So these are, for example, additional modules that we made to make sure that we have additional security constraints in place. So for cross-site scripting, we added stuff. For cross-origin requests, we had additional modules so we can prevent access to our resources, but we can also prevent APIs for exposing course headers from a response. And we can also add additional course headers during the response of an API call. We can also filter based on methods, so we can have additional security constraints on that. And some of the constraints can also be that if we have an employee or a customer, if we identify someone in that specific group, we can apply group policies on that, and we can say, well, if you are part of this group, you are not allowed to post, but you are allowed to get only in this specific location. So we can add additional security controls on that. One of the other filter that we added was the JSON hijacking filter, and that prevents the response to be read by other parties if they are able to inject JavaScript in our content for some reason. And the last one that I already mentioned a bit was the cookie jar, which handles cookies server-side. So, for example, not all cookies are exposed to the browser, because if you are internally hosting quite some applications, and not all applications are stateless, there can be quite some cookies sent to the browser on every request. So we store them server-side, and we act the same as a browser would. So we can pass the cookies only to certain upstreams if they are required, but we can also block incoming cookies if we do not want them. So if a customer, for some reason, adds additional cookies which we did not intend to get in, we block them, and by the end we can merge all the cookies together, so we get a response or an upstream request that has all the proper cookies in it. But that allows us also, for example, for the third-party sites to manage a single session or single login and a single logout solution. So once they log in, we can pass all the cookies to a third-party site, and once the customer logs out, we can also terminate all the session-related cookies that we store in the cookie jar. So it acts as a single login, single logout mechanism. For that, since all the traffic is passing through nginx, we need proper monitoring in place as well. So we added a connector to log all the events in Kafka. We added a connector to add all the aggregated data in Graphite, so we can make dashboards for it. And we also created an omnibus connector, so we can connect to their master control room, which is available 24/7, so they get notified if stuff is going wrong as well. But one of the most important parts of the functionality that we added over time is the authentication. Since that restricts access to the payment areas, but also restricts access to third-party sites. So we know which customer is actually doing stuff and what it is doing, and we can restrict also access to certain parts. Since we also wrote our own load balancing module, which is integrated in the cookie jar, we can also store routing related information in there, so we know, for example, if a customer needs to be routed to a specific server to enhance the request with additional A/B testing functionality, we can do so as well. So we have quite some way of configuring how traffic routes and stuff like that. But also the throttling is something that is quite important. So as you can see, we added quite some functionality on nginx. And nginx is quite good in exposing the ways how we can add functionality. So I want to show you a bit how we managed to get all this additional functionality done without any code change to nginx itself. So one of the things that we can do in nginx is if you make modules for it, you can use the life cycles for that. So the life cycles is actually a way of hooking your code into specific areas of nginx. So it gets called in a specific place and you can decide what to do. So for example, if you make an authentication module, you access on you hook on the access phase, and based on if you say it's allowed or not allowed, it can pass to other filters. So each of them can say if it's allowed or not. So in the way we use it, we are quite heavily hooked on the stuff in the server rewrite phase, the rewrite phase, access phase, and also the logging phase. But as you can see, this is all based on access. But sometimes you want to evaluate the results as well, because as I explained earlier, the CORS, for example, if an API returns CORS-based headers, you want to block them from allowing, for example, a star access or asterisk access to your service. So for that, nginx also has additional hooks. These are the hooks, for example, that we use. So we can evaluate also response headers and response bodies. So we can see everything that passes by, or we can modify any responses. So for example, the hijacking, the JSON hijacking is a part of the body filters. So we can evaluate the body and we can also modify that. So how do these the modules work in a life cycle of a request? So I took something like a normal request that you can see actually if you are doing some on our site. The first one is when the request comes in, we evaluate if someone has actually a cookie jar or not, because it's for us important to know if they need to have additional cookies passed or not. And since it's integrated with the Cassandra, we need to start processing or initiating a query as early as possible in the life cycle of a request. So that is also already done on the server rewrite phase. So if we think we need, or if we know that we need to get a new set of data from the Cassandra, because our node internally does not have the latest data available, we start already an asynchronous query on Cassandra. After that, the additional filters kick in, so we can validate if there is a session available. We can enforce any CORS. So if you are doing a request from an origin that we do not allow, we can block. Or if there's not the proper cross-site request forgery stuff in the request, we can also block. And if that is all passed, but we see that the current node does not have a session in place, we initiate using the nginx way of starting a sub request. We initiate a call to a third-party API to actually call or verify if we have a session for that customer. Since it's not available on that node, it doesn't mean that the customer did not log in, but it can be that it moved to another server or to another data center. For example, if you have round-robin DNS, you can end up on a different server at any time. So once that call is done, it's either you do not have a session and you are redirected to whatever it takes to get identified, or you do have a session at that certain point, and we can fetch the results that is already pending from the Cassandra call. We can merge all the incoming cookies, filter out which one we do not want, merge them together with all the cookies that we already acquired in the cookie jar, and then construct a new cookie header, which we can pass to the original upstream request. And since also the upstream is filtered based on something that we store in a cookie, it does not mean that we can wait until this time all the time to fetch the data from Cassandra, because in some cases, if we need the load balancing decision for sticky upstream earlier, this decision is pulled earlier. So then with that request, we can call the actual API call. We can analyze if any set cookie data comes back. So we can either drop them, absorb them in the cookie jar, or pass them to the client based on policies or evaluations. We can enforce the course header, so we can drop any course headers in the response. We can also add additional course headers if we see that the request was done in a cross-origin manner. And we can also modify any bodies if it was a JSON-related call. So we can inject the anti-hijacking stuff. And once everything is out of the door, we can log everything in Kafka. So that's basically how normal request would work. So where does the token stuff come in then? And that's in this specific area. So once the sub request is being done, we have a possibility to choose which methods we want to invoke to identify a customer. So if we do not know the customer at that time, we do a request, but in this place, we start not the validation of a session, but we do a call to a different API, so that one can identify if it understands the means that is passed in a request. So for example, if an other application requests access to an API and it passes an OAuth token, for example, we can evaluate that and maybe directly give access to that based on that. Or if there's a refresh token in that request, we can already allow that request in based on the refresh token. So if we draw this in a different way, it looks something like this. So we have an nginx. In the left top corner you see means, and in this case it means the different access means that we have. So you should think on username, password, or maybe one-time password, or maybe other devices that we can use, like a mobile PIN or maybe an OAuth token. So you can use all kinds of different means. And once we identify who the customer or the employee is, we can select based from which is available within the channel the means that are possible to request or to identify a customer. So that's all handled in the orchestration API, and that one is responsible to figure out who is trying to get access, which means are necessary, but we can also add different policies. So based on if it is a web channel or maybe an automated application, we can use different policies to eventually determine who is requesting access and who should have access. And based on that, we can also add additional fraud information, so we can see if we need to request more means or not, based on indication that we have. And since all means are coupled to identities, for example, a customer or an employee, we can enhance all those data. So in the end, we know exactly who is trying to access, and then we can create a token using the TokenAPI. And once that is present, it's returned back to nginx. And there we come back in the TokenAPI handling. So the TokenAPI can be stored internally in nginx, or it can be passed outside, so as a bearer token. And that means that every time a request comes in and we see a bearer token, we can validate access based on that. So we can grant access because we know it's an internal token, and we already validated all the risk-based access for that. And in case the access is, or the token is kept internally, we can store it in the cookie jar as a part of functionality, so it's also replicated. So once the call comes in and on another node, we can also pull that data up and use that token again to grant access. So in that case, the flow is a bit different. So still we need to evaluate if we need access tokens to or to validate any tokens that comes in, or if not, if we need access tokens based on what we have stored in the cookie jar. So we can validate if the data in the cookie jar is still valid. We can do an asynchronous call to Cassandra, pull that, and then validate the token. And we can validate all the claims that is part of the token, since we are using a JSON web token, which also stores stuff like claims. And if that is all passed, we can do, or not, we can either do the sub request to initiate a call. So maybe the call was passed as with a refresh token, so we can create a token on the fly, and if not, we have to redirect to where the orchestration server tells to start initiating the one, so the customer maybe. So maybe it has to prompt for a username, or it has to prompt for a mobile PIN if it's a mobile user. So we can decide which flow to start from there. But in the end, the flow is not different if we choose either an employee or customer or any other application requesting access. So by externalizing the decision to have tokens created and evaluated outside of nginx instead of inside nginx, we have a way to add different means easily. So we have a username password or one-time password, but we can also easily add FIDO or any other way to identify an employee or a customer. And that is not, it does not require any change to nginx, because the way nginx works is we validate one specific token, a JSON Web Token, and we create one token with a TokenAPI, and all the risk factors are done in a different area. So specialized teams who are in charge of adding specific means, they can do their thing, and the only result is that once a token is created, we can grant access. So it's neutral to if it's an employee or a customer. Since we use the Cassandra for storage of tokens, it also means that we have to optimize that specific area, because if we have to query every single time on Cassandra, there's an overhead in retrieving the data. So what we had, even before we started tokening with the tokens, we also had to optimize that specific flow. So what we want to do is we want to make sure that we have a latest copy in memory, so we can reduce the amount of queries, and we do not have to do an asynchronous call to pull the data out of Cassandra, but have the latest in memory. So we can pass that specific step and do the request to an API sooner, instead of waiting for the data to become available. One of the things is that Cassandra, if you ever worked with it, uses something that is eventually consistent. So once you write to a Cassandra node, or you can decide if it's either one node in every data center, multiple nodes or multiple data centers and stuff like that. So you know, you can ensure that the data is available for sure, but you need more nodes to commit on a write, or you know less for sure that it is available, so you write maybe on one node in each data center. And that is where you can play around with. So that means that you have to decide how your write consistency is, because a higher consistency means more nodes in your write or your read, and that takes longer to get the access. And if one node is down and it doesn't react, and you say all nodes need to respond, your call will fail. So it's important to choose that one. So also for reading, that's the same. So if you use a high read consistency, it takes longer to read, and it impacts your performance. Another thing that impacts the performance is the way the data is stored, and also the limitation on queries. So what we found out is that once a query starts running and you hit a node that is garbage collecting, because Cassandra is a Java-based application that does garbage collect cycles, you can see that if it hits a garbage collect cycle, it can take longer than your query timeout. So that means that if you see that your query is taking longer, it might be a good solution to terminate that specific query and start another one on a new node, in the hope that that one is not garbage collect cycling. So what I said earlier also, to have a good performance, we try to minimize the amount of times we go to Cassandra. And that means that we only do so if we see that the current node is not properly storing the correct data, so not the latest data. So maybe it failed over to another node. So we also use different consistency levels for write and read. And we use the event loop to stall certain queries or to request for all the data to become available. So that means that if the Cassandra node takes longer to request the data, we can stall that specific request without any overhead. And we also maximize the amount of query time that it runs and retry once we see that it takes longer to respond. So by integrating Cassandra, we had some lessons learned. One of that is that the way we store data is important. So if a cookie jar can grow quite big, especially if you have multiple applications all sending out different cookies, and if you have a model which is time series based, so every time you add a cookie, you add data instead of replacing data, your data footprint in your Cassandra key space will be quite big. And the amount of data that is stored in your key space is quite impactful on the response times that you see. So using more data, or using time series data, affects your response time significantly. What we also saw is that a lot of the times that we saw actually timeouts, and we set it to a certain level which you can configure, you see that once the garbage collects kicks in on those specific nodes, your timeouts are peaked. And this is in this case some of the graphs that you see below. The yellow ones are the ones that are kept before we start tuning our cluster. So we set load and we can tune the cluster more, but the yellow ones are the peaks that you see that actually the timeout kicked in for a specific query. What we also did is we tried to mitigate that to not run a query for a maximum time, but also retry that on a different node. So we hope to get better responses from that specific node as well. And to be able to performance tune your application, you are required actually to expose a lot of variables that are available within Cassandra, where you can tune your driver to expose them as a way in your configuration as well. What I mentioned a bit earlier also is that since we use the cookie jar to store load balancing decisions, we also found out that in some cases, once we switch node, the nginx itself decides which nodes to use quite early in the life cycle. So once you hit that specific node and you don't know what the load balancing decision is, but you know that that specific endpoint requires a sticky configuration, you need to fetch that data. So that will be more or less blocking before being able to proceed to something like the access lifecycle or any other lifecycle. So you stay in the server rewrite phase longer to be able to fetch that data, because the next phase is the configuration phase in which nginx pulls the selected nodes which it will use for load balancing. So overall, what did we learn from this TokenAPI part? What we see is that once we migrate to a solution where the API is external to nginx, we can easily add different means where we can authenticate or authenticate customers or employees or other systems. So it becomes a more pluggable system, and we can add additional functionality, but we can also incorporate other data, for example, risk or fraud-based data in our access. So we can evaluate more data than we could if we only looked in the data that was available within nginx during that time. But also by reducing the way we manage access to using one specific JSON Web Token, the same token can be used for all different ways of access, so customers or employees or applications. That simplifies the solution in nginx quite a bit, and it only adds to the complexity of different teams, so they have to create new microservices to expose those means. So if there is a new means available, they can decide which means they want to add, and they can do it themselves without any change to nginx. So that's a quite powerful way of adding functionality. So what I want to say is, as you saw, we created quite some modules for nginx on different areas, also on token access management. And as you can see, we didn't change any line of code to nginx to be able to do all these kinds of functionality. So nginx allows you quite a bit of freedom to change or enhance anything on an open source nginx version for anyone. Are there any questions?
Yes, so on one hand, you kind of said you modified the nginx event loop in order to put your own database file handles in there to be able to do asynchronous database queries, right? On the other hand, you just said you didn't modify nginx.
We did not modify nginx. What we do is, in the server rewrite phase, we initiate a call to start fetching data in Cassandra. But once we know that the data that we need is also needed for the evaluation which upstream node we want to hit. So if you have a pool, like an upstream pool, and you have 3 servers in there, and you know that last time you hit server 3 for that specific customer, and it's an HTTP type of session, like a stateful application. So you need to make sure that if you choose another node or you choose another data center, you have to use that same server with the same cookies to access that request. So you have to wait for the data to become available in from Cassandra to be able to select server 3 with all the stateful cookies that are needed to do the actual call to the upstream server. And since nginx decides which server to pick just after the server rewrite phase, but before the access phase, you cannot proceed with the other modules, and you have to stall that request using the event loop. So what we do is we wait until the data comes available if we know that that data is required for load balancing. So we use the event loop to stall that request for a certain period of time to the maximum of your timeout, your maximum timeout limit. And after that we proceed, well, in that case it's too bad that we could not pull all the data from Cassandra, and we proceed anyhow. So we have a 1 in 3 chance that you hit the correct server, but if the data still does not contain your HTTP session cookies for that application, your session will be broken anyhow. So we did not change anything, but it's the way how we interact with the event loop to stall a request if we need to wait for the result to become available to proceed.
You mentioned that you load a cookie jar, Cassandra only return memory copies allocated. What about data pieces? For your context specifically, for ING, what is happening?
Well, we can keep track of, we know based on the cookie if we have the latest or greatest data available in memory or not. So we can relate the data to the actual memory copy available. And if we see there's a mismatch, we can reload the data.
But is there a time requirement?
There's no time requirement. Oh, well, there is actually some time requirement, but it's not restricting in a normal way. So it's only like an expiration. So in activity, for example, can make sure that a cookie jar is removed. So once a customer clicks away the browser, for example, or doesn't do anything for a certain period of time, it needs to be removed because we cannot keep around stuff for infinite. So
I'm just curious from an interaction model, what's that duration?
yeah, that's configurable. Yeah, so we can change it to any setting we want. So we can change it for internal size different than for externally. Yeah.
Does it have any effect on what type of load balancing algorithm do you use?
Now we use round robin, but we can choose to have, well, for example, the load balancing, we enhanced on that. Normally you have something like the active pool, a backup pool, and you can choose if you use the active pool and the backup way, so you can stovepipe request, for example. So say you place one upstream node in the active one in the backup pool, you have two nodes to select, one is, and basically you are stovepiping. If you add more to the to each pool, you are round robin load balancing within every pool. But we added another pool as well, so we can also say if it's not available in one of those other pools, all traffic is routed to another upstream. So for example, if you have an application that serves a page, and that page is like the frame of where APIs are being called for, you don't want that page to fail completely and send out an HTTP error page. So in that case, we have a failover mechanism which can send out a pretty page based on the error that occurred for that specific upstream.
This said quite a few problems with Cassandra. Did you look at any alternatives to Cassandra? Why do you think Cassandra?
Well, initially we wanted to look at Redis. But we also have well, as we are the experts internally on using the nginx or enhancing nginx with additional modules, we also have teams that are very knowledgeable in hosting and giving out resources on Cassandra. So it's for us an easier way to get that going, because they have the knowledge on that. We can leverage on their hardware, we can leverage on their cluster, and they manage everything there, so they can make sure everything is upgraded. So it's part of a service, maybe, if you can see that, to use that. So it takes quite some load of our team to start using different technology and use that one based on that team and their knowledge on that. So in that case, we use or chose Cassandra, but that maybe also takes a bit of additional tweaking to get things working.
It seems like a lot of code and moving parts. Can you develop any useful techniques for debugging all that code?
It is quite some code, indeed, because we use quite some of the internally stuff available within nginx, but as you see, we have additional modules for quite some additional functionality. And we use, well, test cases to make sure that we test every individual module by itself, and we test everything as what we create in a build. But it's more difficult, like Java, you can inject stuff and you can pull out individual classes, for example. It's easier to test. So it's for us mainly making sure that we black box test everything. So we have quite a lot of test cases, so we test all the functionality, all the corner cases we try to hit on configuration stuff. And if we find a bug, we try to make sure that we cover all the additional areas that we find by fixing the bug. So we have more test cases, well, and do not introduce the same stuff again. But it's a bit difficult because C does not lend very well for small debugging parts, at least. Anyone else? Thank you very much.